All right, pre-calc 11, here we go. It's late in the evening on in the end of May here, early June. Here we roll. Okay, we're gonna look at rational expressions and equations. So, this is the topic, rational expressions. And we're going to look at multiplying and dividing them, and we're going to talk about something what are called non-permissible values, or I like to call them restrictions. There's the practice. So, bear with me. Here is what a rational expression is. You've seen them before, we just haven't named them. So, what is a rational expression? So here are just 4 random rational expressions. Basically, a rational expression, because these are all rational expressions, is a fraction of polynomials, and generally there'll be a variable in there somewhere. So notice this is just a binomial divided by binomial, monomial divided by trinomial, monomial by monomial, and such. That's what a rational expression is. So what are non-permissible values? They're basically restrictions. When it comes to like a fraction, when it comes to fractions, the only trouble with a fraction ever, if there's variables involved, is the denominator cannot be 0. You cannot divide by 0. It is the only number you cannot divide by. So if I went like 8 divided by 0, I will get an error. So if the denominator is 0, that is bad. And that's going to lead to restrictions, which lead to what are non-permissible values. So here are 4 examples of rational expressions, and if they asked you what are the restrictions or the non-permissible value, you will focus on the denominator. So here's our first example. Let's look at this guy. 2 over 4x minus 4. So let's focus on the denominator. The denominator, this is not allowed to equal 0. So what would a bad value of x be? If I solve this inequality, if you were, I can move the 4 to the other side. A bad value for x would be 4, because 4 minus 4 would make this a 0, which would be bad. So there is my non-permissible value. X cannot equal 4. So for this rational expression, x can be anything except that. That's what a non-permissible value is. Look at the next denominator. So rational expression, good for it. Focus on the denominator. What makes the denominator, I always think of it this way first. What makes it equal to 0 first? Like do kind of what you know. And because it's already factored, what value of x would make this 0 would be 4. But because it's in the denominator, it's a bad value. X cannot be 4. What can x not be here? X cannot be -9, because if it was -9, this would be 0, and 0 times anything would be 0, and that would be a bad denominator. So look at the next guy. Look at the denominator. What's a bad value of x? What can x not be? It cannot be 0. And for this guy, what x value here, 9 times what plus 5, would make that equal to 0, which would be bad. So where is that not equal to 0? Well, solve that. Move the 5 over, subtracting, divide by 9. -5 over 9. Very much like how you solved an equation, just you're looking for what it's not allowed to be. So x cannot equal -5/9. So that's what a non-permissible value is. Denominator equaling 0. Bad. All right, so next step is they're going to give you like expressions like this. They're going to give you some kind of rational expression that's going to be multiplying. We're going to look at dividing today too. So here you got a rational expression times another rational expression. So they want you to simplify it, and then they always will ask you to state the non-permissible values. Before we do this fraction ugliness, let's go back to grade 9 for a minute, grade 8 for a minute. How would you have multiplied regular fractions? Well, when it's just numbers, you would have gone numerator times numerator or denominator times denominator possibly, or you could look for common factors, numerator and denominator, that you could divide out. So for example, here, you might look at that and go, okay, I can see 7 and 21, they have a 3 in common. I could divide this, well, 7 in common, sorry. I could divide this 7 by 7, give you 1, and divide 21 by 7 to give 3. And in the same token, you could have looked at the 5 and 10 here. 5 goes into itself once, 5 goes into 10 twice, and then you would have been left with 1 times 3, 3 over 1 times 2, 2. I mean, the other way you could have done it is multiplied 5 times 21 first off, and that'd be 105 divided by 70. And then you could have put 105 over 70 into lowest terms, and you would have come down to this. So you can divide any numerator, denominator, common factor out first, and then multiply top, top, bottom, bottom. So coming back to one like this, now here's where you got to be so careful. As soon as they throw a plus or a minus sign into this, canceling like this is not directly done. The first thing you must do is not fall for any temptation here. And this is really important. The very first step, and this is so important, you got to tattoo actually this whole unit. Factoring is your number one thing you would do first. So as soon as I see this, I don't even jump into anything except I'm going to factor the heck out of this. So a plus 2, very simple, doesn't factor. Now anything that doesn't factor, that's kind of a binomial or trinomial, put brackets around it. 3 does not factor. You could factor 12 if you wanted to. You could make it, you could prime factorize it. It could be 2 times 2 times 3. I don't have to prime factorize that, but maybe I will. And a squared minus 4, that just absolutely screams difference of squares. A plus 2, a minus 2. So as soon as you've factored everything, why factoring is so beautiful in a multiplication division world is it created everything here is multiplying. And these little brackets are like little packets. Like a plus 2 looks like two numbers, but it's really 1. Now what you're allowed to do, and then actually before I do anything next, after I factor, then I look for restrictions. So I should make a little note. What are bad values of a on the denominator? Well, here, this denominator is not an a, so it's safe always. What's a bad a here? That would be a cannot equal negative 2, because that would be 0. What's a bad a here? A cannot equal 2. So my final answer, a cannot equal 2, and a cannot equal negative 2, coming from those two denominators. So I'm going to keep that in my back pocket. That's part of my answer. The next step is now I can, I'll put this in quotes, cancel. Just like up here, you could cancel, you divided by 7, divided by 7. Here, you've got a few things that you can divide out. Now, this a plus 2 will divide out with that a plus 2 because they are identical factor packets. This 3 can divide out with that 3 because notice it's all multiplication. Cancel, cancel. And what I'm left with is 2 times 2 on the top, because remember when these divide out completely, they're left with imaginary 1s. So that's left with 2 times 2 on top there, and the bottom's just left with a 1 times a minus 2. I could put a 1 there if I want. Now one thing that you got to be careful with, it's so tempting. Those 2's look like you can divide them, but you cannot because that's an a minus 2. This cannot divide out at all because this is not a times. So your final answer is 4 on top, 2 times 2, over a minus 2 with those two restrictions. So it's kind of a corny thing. When I see a multiplication question like this with rationals, first thing I look at is big and clumsy. It seems weird. I think frick. Factor restrictions cancel. Factor restrictions cancel. And there we go. Okay, example number 2. First of all, I see a rational expression times a rational expression. Frick. So now I'm going to look at all of this and I'm going to factor every single numerator. It's almost like having 1, 2, 3, 4 grade 10 questions thrown at you to factor. So let's focus on this one first. How do I factor that trinomial? Well, if it factors x and x, what multiplies to give negative 12 and adds to give negative 1? Oh, negative 4 and plus 3. Works. Denominator, that's a difference of squares. Kaboom, x minus 3, x plus 3. This, another trinomial. If it factors, has to do something like this. Multiplies to give positive 3, adds to give negative 4, negative 3, and negative 1. That cuts it. And the denominator looks like a difference of squares. If that x wasn't there, difference of squares beautifully, but that x makes it not a difference of squares because that x is off. But I could do a GCF and just take an x out. There's an x in common. I'm just left with x bracket x minus 4. Once I've done that, my next, so there's my factoring done. Restrictions. Look at your denominator and pick off all the bad values. Sorry for the shadow here. It's dark and I got a light. My apologies. So, bad value of that x, 3. Bad value for that x, negative 3. Bad value for this x is 0. Bad value for that x is 4. There's a whole whack of restrictions. So 3, negative 3, 0, and 4. And now comes the fun part. I love this part. This is like therapy to me. Because everything is multiplying, I can now divide out any common factor packet. So x minus 4, x minus 4, gonzo, leaving behind imaginary ones. Anything else? X plus 3, goodbye. X minus 3, goodbye. And now what am I left with? That's the only packets that are identical. These are so far off, even though that's just like, well, why can't I cancel those x's? You cannot. So you're left with, on the numerator, 1 times 1 times 1 times x minus 1 is just x minus 1. On the denominator, 1 times 1 times x times 1, just left with x. And that is your final simplified version. The poor sap that divided those x's there, that's just like driving along, having the best driving day ever, and you just jumped onto the sidewalk and started running over people. It's not good. Okay? That is your final answer. All right? So it's kind of fun. I like this stuff personally, but that's just me because I'm weird. So next guy. Multiplication of rationals. So I think frick. Factor. Well, here, notice there's no adding here, which makes my life easier and harder. So there's no trinomials, there's no difference of squares. I could do, the only factoring I can really do is maybe a prime factor tree for 4, which is 2 and 2. I could do x squared could be x times x if I wanted to get really witty. The bottom is just 3 times x times y. Y squared is y times y. 8 I could make into a 2 times 2 times 2 times x. I don't have to do that. So that's done. While I'm at it, what are the bad values? So notice, what's a bad x that would make this multiplication 0? Well, the only thing that can make this 0 is 0, because 3 times 0 times anything is 0. So x cannot equal 0. That 3 is not even worth looking at because it's always a 3, will not change. The y could also not be 0. And then looking over here, well, x cannot equal 0, already taken care of. Okay, so that's done. Now cancel away. Everything's multiplying. That 2 and that 2 divide out. That 2 and that 2 divide out. Now I can do this x and this x, or that x and that x, or that x and that x, whichever one I want. I feel like crossing off this guy. And then I got a y I can cancel. Anything else? Sometimes if I don't see any more, I just write out what I'm left with. So I'm left with, remember these are all 1s. So I'm left with xy on top. And I'm left with 3 times 2 times x, which is 6x. And at that point, you might have saw it earlier, I could have canceled that x out. I didn't see it till now. Oh yeah, those x's could have canceled. And you're left with y over 6. So who would have thunk that question there, that mess, is the same thing as y over 6. And that's why math people do this. Would you like to work with this or that? I'll take that any day. But it has some restrictions I got to keep in my back pocket. Okay, next one. And then we're on to dividing. Okay, so I look at this. Again, rational, rational, frick. So I'm going to try to factor everything that I can. The first thing that jumps out at me out of those four, that's difference of squares. X minus 3, x plus 3. So you're done. This one's kind of bugging me a little bit. I'll leave it for a moment because notice it's not a trinomial, it's not a difference of squares. It's kind of backwards. We'll talk about that guy there in a moment. Here for this one, the only thing I can see for 4x is maybe a 2 times 2 times x. This one, I can see a GCF of 2 and an x, so let's take it out. And I'm left with 4x minus 1. Good. Now this one, just as a hint, I know what to do because I've seen these enough. Because this is kind of backwards, we're so used to having x first, I'm going to, in a sneaky way, factor out a negative. Now if I factor out a negative, this becomes a positive x, and this becomes a minus 3. And I'll just double check this. If I FOIL that in, minus x plus 3. So it's just a witty way. If you see something backwards, I can factor out a negative 1 if you want. I'll put a 1 there. So now I've done all that. Let's look at the restrictions. What are bad x's? 3, negative 3, 0, because 0 times 2 is still 0. 3, negative 3, 0, and, what makes this 0? Oh yeah, I should know that, but if I don't, make it equal to 0, move, it's really not equal to if you want, and then divide by 4. Oh, it's a quarter. So 3, negative 3, I can write that as plus or minus 3, 0, and 1/4. There's my bad x's. Now comes the therapy part. This factor can cancel out with that factor. This 2 cancels out with that 2. That x cancels out with that x. I think that's all I'm left with. So my numerator is negative 1 times 2, which is just negative 2. Denominator is this times this. I won't even bother foiling that out because factoring is beautiful. I'll leave it like that. I could distribute that out if I want, but I don't feel like it. And is there anything else I can do? No. Why can that 4 and 2 not divide out? Because this is the minus there. That cannot cancel. Like, you're hurting people if you do that. Well, you're hurting the math people anyway. And there's my final answer. Okay, last few examples are dividing. So we have 2 examples of this and then we're done. So they're going to ask you to divide rationals. The good news is dividing fractions is really something you've done before as well. So let's go back to dividing way back in grade 8 and 9. When you divide fractions, remember the rule is you reciprocate the second. So flip that head over heels and change this to a times. And once that changes back to a times, you're just doing exactly what we just did for the first 4 examples. I would personally, 3 divides into that once, 3 divides into that 3 times, 2 divides into there once, 2 divides into there twice, and you're left with 3 over 2. So following the same process here, it's basically frick, but before you cancel, here you gotta flip. It's a flip and frick. Okay, so here we go. Or it's a frick flipping. Here we go. So factor everything. Difference of squares. X plus 2, x minus 2. The bottom is actually another difference of squares. 2x minus 1, 2x plus 1. This numerator there is a GCF of x. That denominator, if it factors, there's no GCF. A 2x and an x. Let's fool around with this. I think that's a 3 and a 1. Minus minus, double check. 2x squared minus 6x minus 1x. Yep, minus 7 plus 3. Factored beautifully. Restrictions. What are bad x's? So what makes this x make this 0? That's 1 over 2. Remember, it's opposite sign, that over that. Here, opposite sign, that over that. Negative. So plus or minus 1/2. That's another half. That is 3. Bad value of 3. Okay, but now before I cancel, I need to flip this. So this whole back end, just like this one, has to flip. So we're left with this mess. Change it to a times. Flip this over. Now, one thing that happened here that's interesting, as I flip this, created new denominators. So there's more restrictions in here than meet the eye. There's a 0 and a 4 that are bad. Be careful with that. That's sneaky. Now the fun part, canceling. So x, 2x minus 1, 2x minus 1. What else we got? I think that's it, isn't it? Nothing else is identical. So here's my final answer. X plus 2, x minus 2, x minus 3 on the numerator. The denominator has a 2x plus 1, an x, which I can put in the middle. I like to put it at the front, personally, and an x minus 4. Not a lot of simplifying in this question. A lot of hard work to not make it look much better, but that's what I would do. Alrighty, last one. Whoa, upside down. Notice it's a mixture of dividing and multiplying. So, first step, let's factor away. Does that factor? Well, if it does, it's a 2m and an m. There's no GCF. 15, 5 and 3. Yeah, if I make that a 5 and that a 3, I think that's the winner, because that makes that a negative and that a positive. Double check. Boom, boom, boom. Yep. Denominator, common GCF of 2m. Difference of squares, 2m plus 3, 2m minus 3. 2 I can do as a, or 6 I can do as a 2 times 3. This, nothing I can do except I don't like the backwardsness of it, so I might factor out an imaginary negative 1. And that would give me, sorry, yeah, change the sign to give me a 2m minus 3. Okay, restrictions while I'm at it. Bad m 0, bad m 5, no denominator there, no denominator there, and then there is no denominator here. I'm going to put that over an imaginary 1. That's the only sneakiness there. Okay, I got to flip this guy though. So 2m plus 3, m minus 5, 2m, m minus 5. Flip this turkey, change it to a times. A lot of rewriting. The only reason I can write fast, in all honesty, is because of these questions. Did that create more restrictions? Yep, new denominator, more restrictions. Out of there, bad x or bad m's, negative 3 over 2 and positive 3 over 2. What cancels? 2m minus 3's, a 2, a 2m plus 3, and I think that's all she wrote. On the numerator I'm left with this, this, and a negative 1. So I'll write that as a negative 3m minus 5 over, oh, I see something I missed, but I'll get it in the next step, over an m and an m plus and an m minus 5. That doesn't, and that's just a 1. And I missed it here. I should have done it right there, but there's my m minus 5. And who would have thunk? Look at that big mess, simplified all down to that with these restrictions. And that's all she wrote. Alright, so this is just proficient math. In all honesty, I didn't practice any of those prior. I wrote them out from a book. The factoring of those, you just have to practice these until you just become really quick at them. That's for your calculus and pre-calc 12 coming up. Alright, have a good day. Talk to you later.